My name is Frank, and this is PothOnProgramming. Welcome to part 17 of the Stay Down devlog. It's been a while since I made a video or did any work on the project. I think about 7 months. So today's video is basically just going to be the state of the project now. I'm going to talk about some things that I think will interest you in the project now, but I'm not really going to go over how the project was. We're just going to be taking a look at the current state of the project. So first I'm going to go over the framework. Then I'm going to talk about loading objects in dependency order. Then we're going to talk about switching from inheritance, class inheritance, to object composition, which I'm using now, and I think it is working really well so far. I like the way it looks. Then we're going to get into some changes to the game. The Dominique image now flips on the x-axis to face the direction she's moving. I added collision with the walls. And I added a behavior for the diamond item, so it actually runs away from the player when you chase it. And as it stands right now, the AI needs some fine-tuning for sure, but I'll just show you that so you can get an idea of how it's going to work, because the basic idea of the AI is there. It just needs to be fine-tuned a lot more before it's usable in the game. So if you learn anything while you're watching this, definitely like the video. Let me know in the comments. If you have any questions, leave a comment. If you want the source code or to take a look at the working example, I'll leave a link to the website, PothOnProgramming.github.io, in the description. And I hope you enjoy the video. Let's get to it. So first things first, I want to talk about the framework for the project as it stands now. This is the HTML. And I'm loading up all my files. The important thing here is that I load the staydown.js file first and the initialize.js file last. All the other files for the game get loaded in whatever order that I want, so alphabetical order for now. And as they get loaded, they're going to populate one big overarching global game object, which is called stay down. So inside of my staydown.js file, which gets loaded first, I just have a simple global object called stay down, and I have a bunch of nested objects here which represent the different logical parts of my game. So I have buffers. Buffers are just like the background buffer that you see here, like this big tile map. I've got a buffer for the spikes on the top. I've got a buffer for the text background. I've got a buffer for the text. So, I can move that buffer around when I pause or when I quit to put the text buffer wherever I want. But basically, I got a bunch of different buffers. Images just holds my actual image references. So that's going to be the actual graphics. That's a terrible example of a graphic because you can't even see it. But it holds my actual graphics, like the spike graphic. All the graphics live. Where did that even go? All the graphics live in this images object once they're loaded. Then I have initializers. Initializers are just methods, so functions, that create some of the objects, some of my game objects that have dependencies. The reason that I have these functions, you could think of them like constructors. The reason I have these methods is because some files depend on other files being loaded first, and one example of that is the player. The player needs the rectangle to be loaded first. This way it can inherit the rectangle properties. So this function just allows me to load up the player file, and then when I call this function, that's when I look up the rectangle object, and then I can use that rectangle object to create my player, which inherits from the rectangle object's properties. So all of my initializer methods get stored in this staydown.initializers object. Let's take a look here. We've got states. The states object holds all of my game states. So if I go to, let's see, game states folder, we could take a look at the title game state. Now, the title game state needs to be initialized. So this is the initializer method, which we just talked about. But when I actually do call the initializer method, I set staydown.states.title to the title game state object. So all my game states live in the states object. Tools. Tools are utility. Well, I guess they're not utilities because I have utilities, but tools are tools. The controller object is a tool. The game engine object is a tool. The engine is the thing that controls my game loop. The controller obviously has all the functionality for my controls, and I did explain these files in great detail in previous episodes, so check those out. I got the loader. That's a tool that loads up all of my images for now. Maybe it'll load audio in the future. I've got the state manager tool. This just allows me to switch between the different game states, so I could pause, quit, play, that sort of thing. It's a really simple file. We've also got the text tool. The text tool is responsible for drawing all of these different text characters from the text image to the screen. So, got tools. The last thing I have is utilities. Now, you're probably all familiar with this utility, the math utility. The math utility has neat methods for working with math, like cosine and sine, and we could use those methods. They're defined directly on this math object. My utilities, some of them are going to have constructor methods in them to create different objects. So, for example, rectangle 2D is a utility. The rectangle 2D object has a bunch of functions, just like the math object, for manipulating rectangles or doing stuff with rectangles. Like the math utility has functions for doing math stuff. The rectangle utility has methods for doing rectangle stuff. Just like the collider utility, I moved all my collider methods out of the run game state and put them in here. And the collider utility has a bunch of methods for doing collision. So we have collide top. It takes a rectangle and the top Y position that you want to collide that rectangle with. We have collide player with platform. Obviously that collides the player with the platform. I just have to supply those players and platforms to the function. So we have a bunch of different utilities here. Some of the utilities also have a method to create. The create method on my utilities creates an object of that, I don't want to say type, but it creates an object with all the properties you need to run these methods on. So the rectangle 2D utility can create an object with the create method that has height, width, x, and y, like regular properties of a rectangle. We also have old y because of how we do our collision. I covered that in a previous video as well. The methods of the rectangle utility will take a rectangle object and be able to manipulate it so long as it has these properties. So that is my utilities object on my overarching stay down global object. And these are all the logical parts to the game so far. All of these files get loaded into these different logical groups at some point, and that's that. Everything gets initialized in the Initialize.js file. So the Initialize.js file is here, and it runs. If we look at the HTML, so we define our global object, our global stay down with all those different logical groups nested inside of it, those logical group objects. Then we load up all of our other objects into those logical groups. Then finally we call initialize, and that's where everything gets put together and we start the game engine running. So let's take a look at initialize. So inside of the Initialize.js file, we just have an anonymous function that calls itself. All of this stuff executes. The reason we put it in an anonymous function is to keep this stuff out of the global scope. So we get a short reference to all of the, well, most of those logical groups. So if we take a look at our logical groups, we've got staydown.buffers right here. So here we have the constant buffers, and we're setting that to staydown.buffers. And that's just so I don't have to write staydown.buffers every single time I want to set or get a buffer. Same thing for images. I don't want to write staydown.images. So these are just shorthand references to some of those objects inside of my global staydown object. We come in, we get the buffer utility. That's going to allow us to go ahead and create a bunch of buffers. We initialize a bunch of stuff. So initializers is just staydown.initializers. That's those methods that I was talking about. And we call those to create our objects at opportune times. I'll talk more about that when we go over the next part, instantiating things in dependency order. We set up a resize function so we can resize our screen and the game should resize itself. And then we load our images. And after we load our images, we know it's safe to set up the buffers. We set up our buffers here manually, just right there in the script inside of the initialize file. I might move this out at some point, but we set up our different buffers like the background, tile graphics, the sprite buffer, all that stuff is being drawn here from our individual image files. Then finally we activate our controller, which just adds the event listeners to capture key presses. We have the state manager. We tell it to change states to the title screen. So when we first boot this up, this runs, changes the state to the title screen, and finally we say tools.engine.start, and that starts up the main game loop. And that's it. That is the structure. That is the framework. And as you can see, it's very simple. Everything is simplified down from the last time you saw this project. And I think it looks pretty clean. So pretty happy with that so far. And this really works for me to just keep things organized. And honestly, like jumping back into this project after 7 months was not hard, because everything was really well organized and the files were separated out into nice logical folders and stuff, and it matched up with how the framework is organized. So it wasn't hard to get back into this project. So I'm thinking this is a pretty good way to organize stuff. All right, on to the next part. All right, now we're going to talk about initializing our game objects or our files or whatever you want to call them in dependency order. Now this is going to deal with this logical group in our framework, the initializers object. The initializers object is going to have a whole bunch of methods in it, and all those methods they're like one-time call methods that you only need to call once at the start of the program to set up some of our objects that have dependencies. So here we can see this file doesn't have one. I'm directly setting staydown.utilities.rectangle2d right here. And when the browser parses the rectangle2d JavaScript file, this just runs and it creates this rectangle2d object. Alternatively, we have the player utility. Now the player utility does need to be initialized because it has a dependency on the rectangle2d object being defined. So we need this to be created, so the browser needs to parse this before we can reference it, because if it's not created and it hasn't been parsed, we can't reference it. It hasn't been created yet. So if we tried to set rectangle2d to staydown.utilities.rectangle2d before the rectangle.js file was parsed, it would just be undefined, and we'd probably get an error for trying to access something that is not defined yet. So this here, we create an initializer method, and what this does is it allows us to parse this player.js file and create this player utility method and store it in the initializers object, and then we can call it whenever we want. So when we call player utility, that's when it's going to try to look up rectangle2d, and that's the trick, because in the HTML you can see that it loads up player.js, then it loads up rectangle2d.js. So when it loads player.js, all that happens is it creates this player utility method, and then when we go to initialize things in the initialize.js method, that's when we call player utility. So that's when we call the player utility method, and if we come back over here, that's when we get this reference to rectangle2d. By the time we call this player utility method, rectangle2d has already been loaded, because here it is in our HTML, and we don't call that method until we do initialize.js, so we know that the rectangle is going to be available. So let's take a look at that again. Here in initialize.js, we just go to staydown.initializers inside of this initializers reference here, and we just say player utility. We call the player utility method, it runs this, it gets a reference to rectangle2d, it creates staydown.utilities.player, sets it equal to this object here, and then That's it. We have instantiated it. Now, you might be thinking, why don't you just order these files correctly in your HTML? And you totally can. You can totally do that, and I would be doing that if I didn't run into this issue that I'm going to explain to you now. And that issue is some of these files depend on images being loaded. And actually only one of them does at this point in time, but there's no reason that more wouldn't in the future. And when I introduce audio, that might also create weird dependency problems. And I don't want to rely on the browser to load up my images and then load up my scripts, because I just fear that it wouldn't go as smoothly as I think it might. And I know there are attributes like async and defer that you can use to control that, the order things load in and when things finish loading, other things start loading, that sort of thing. But I would much rather just stick with the fine-tuned control I have with JavaScript inside of my Initialized.js file to control that myself. So let's take a look at the exact case where this is a problem with the text tool. So here's my text tool.js file. It's loaded right here in the HTML. At this point, none of my images have been loaded because I don't even attempt to load them until Initialize.js is called. So when this thing loads, I can't create the text tool yet because my images haven't loaded. So all I do is when I load this file, I say staydown.initializers.textTool is equal to this method. And then when I run this method, I try to get a reference to staydown.images.text. And that is my, if I go to media/images, that is my text sprite sheet. It has all the different characters for my text, and this is what I use to draw out the text on the screen. So it gets a reference to that here, and the way that I do this, let me go over to initialize. The way that I make this work is simple. I just have to make sure the image is loaded before I call that text tool function. So in my initialize method, I start it up, I'm going along. Right here, I say tools.loader.load images. I load up my images, and I have a callback function here that gets called after these images are loaded. So after the images are loaded, I set all of my image references. So images.text equals the appropriate text image that got loaded up. Then I can say initializers.textTool, and I can call that text tool initializer method, and I know that images.text is going to have an image in it. So I can go over here to my text tool, and when I call text tool, it's going to set image equal to staydown.images.text. And then down here in the write method that actually writes text graphics to the screen, I can use image as just a reference to that text graphic, that text tile sheet. So this has been my way of getting around this problem, so I don't have to rely on ordering my JS files and relying on async and defer and that sort of thing. I'm just doing it, I'm hard coding it in the initialize.js file. If you guys have a better way of doing this, go ahead and let me know in the comments. This is something that I just kind of threw together. I took a little bit of time to kind of like work it out, and I kind of like where I'm at with it now. I like this approach of initializing everything in the initialize.js file, but maybe it could be better. If you know a better way, please leave a comment because I would love to hear what it is. And anyway, I think that wraps it up for this part. If you have any questions, leave those in comments as well, and I'll try to answer them as best I can. Let's talk about object composition. So I used to use class inheritance and prototype inheritance in JavaScript, and I always had a ton of problems with the hierarchy, like the tree of inheritance. Anytime I wanted to add new stuff in, like new properties, I had to like think about how is that going to affect inherited classes. How is that gonna, do I have to change my base class? Do I have to make another base class so I can like move stuff around? It was just a hassle. With object composition, I kind of step out of that inheritance tree model and everything's just kind of flat. You know, I have a bunch of different objects, right? And those objects have methods, and those objects have properties. And if I want this object's properties, I just mix this object with this object over here because I want those properties as well. So I just mix them together and I get another object. If I want to mix 5 objects together, I just mix them together and I get one object. So there's no tree. I'm not saying, I want a tractor trailer, so I'm going to inherit from the vehicle class. That's going to then, the car class is going to extend that, and then the truck class is going to extend that, and then the tractor trailer class is going to extend that. It's not this big hierarchy. It's just, I'm going to take, the vehicle class, and I'm going to take the trailer class or object. I'm going to mix those together, and I'm going to get a vehicle with a trailer, and that's going to be my tractor trailer. So it's a lot simpler, and I'm doing away with prototype inheritance. So let's take a look at this. I'm just creating an object I'm calling it a utility, and this object has methods. These are the methods that I would typically put on a rectangle prototype. So my rectangle 2D class used to have a prototype, and these were the methods that live in the prototype. So anytime I want to make an object that has these methods available to it, I would have to make it inherit the rectangle prototype. So I'd copy the rectangle prototype into the prototype of that new object. And technically, this is still object composition. Doing it that way was still object composition. This is just a different way of doing it that's a little cleaner. So I'll just get into describing what the utility objects are, because maybe that's a better way to go about it. But here is my rectangle 2D utility. All it is an object. It has a method to create an object which represents a rectangle. It's going to have height, width, x, and y. It also has old y, and we went over that in a previous video. That's used for how we do collision. But our player inherits from rectangle, our item inherits from rectangle, our platforms inherit from rectangle. So I'm not doing inheritance anymore, so how do I get this to work? Well, I have this object that has these properties, and I have this object that has these methods. All right, so let's go over to the player. The player inherits some properties from rectangle, but essentially it's the same thing. I have staydown.utilities.player. All it is an object, and it has a bunch of methods on it. Now, these aren't in a prototype, so if I make an instance of this object right here, it's not going to have a prototype that has these methods on it. It's just not. Instead, how I would get these methods to work is I would say player.jump, and then I would pass in the instance of this object that gets created, and it would manipulate these properties to make it seemingly jump. Here, we're inheriting from the rectangle. So we get the reference to rectangle up here, and then in here, we use the spread syntax to copy the properties off of the rectangle that gets created into this new player object that gets created. So basically, I'm just inheriting properties. I'm not even inheriting. I'm just copying properties into the new object. And anytime I need like a prototype method or something, in practice, I'll just say player.jump, and I'll pass in the player. So let's take a look at how this actually looks in the run game state where we use this stuff. So I'll try to find an example here. Here's the reset method. So when we reset the game, I'm not sure how this works. This might be when you hit the spikes, or maybe it's when you reset the entire game. But in any case, when reset is called, I set the left side of the player to 2. So that's why if I jump up and hit these spikes, the player gets warped back right here to an X position of 2. The left side of the player is set to the second pixel in from the left. So this looks a little weird. Before, what this would look like would be player.setLeft 2. Now that looks a lot nicer to look at, right? But the problem is you have to deal with all those issues of inheriting the prototype to get this method on the player. which is a real hassle. The other issue is, what if I want to set left on the item? All right, well, that means the item also has to inherit that prototype to get that method. But what if I just don't want to deal with prototype inheritance at all? If I don't want to deal with prototype inheritance at all, I just use this approach. I have this rectangle 2D object. It has my set left method right here, and I can just call it on anything. I can call it on any object I want, whether it has, doesn't matter what the prototype is, and I just pass in the value for x. And then it just runs this and it sets r.x to x. So r would just be the rectangle object or any other object that has rectangle properties. And that's how that works. So this is a little bit more verbose. Obviously, it's a little uglier to look at, you probably think, but I can come in here and I can call rectangle 2d.setLeft on player. I can call it on item. I don't know if that's going to work or not, but let's see. As you can see, it starts out at 2. When I hit it again, well, that must be for when we reset. So when I quit and actually reset the game by quitting out and playing again, the diamond should start out at 2, and it does. Doesn't do anything with the Y. So if we come in here, 2d.setTop, set it to 0. Now it should start out in the top left corner. If I save, refresh, play, see how it started out in the top left corner there? So I can call this on anything. It just has to have those rectangle properties. And I kind of like that approach because I don't have to do any prototype inheritance or any object.assign, object.create. And the other neat thing about this is when you are using prototype methods, like say I want to say player.setLeft. When I say player.setLeft, what happens is the player object is searched for a setLeft property, whether it's a method or a property. So it searches the main object. If it can't find it on the main object, then it reaches out to the prototype. And the prototype is where we would typically have this. So first it does a search on the object itself, the instance. Then if it can't find it, it branches into the prototype of that object and searches for it there. So every time we call a prototype method, we're essentially doing a needless search on the main object, which kind of sucks. With this approach, we're directly calling the object we know the method is on, and then the method that's definitely on that object. The other great thing about this is with JavaScript prototype inheritance, at least with object assign, you're literally copying the prototype of one object into the prototype of another object. So all the methods and properties on that original prototype you're copying from are being redefined again in another prototype object. So if you change the original prototype, at least with object assign, it's not going to even apply to the next object, which kind of sucks. With this, your function is only defined once because you never copy it. Set left is only defined in one place in the entire program, and that's right here. So anytime you change this, it's going to change it across the board for everything. So I think there's a way to do prototype inheritance correctly without object.assign, but I could be wrong. In any case, it's really confusing to actually learn that stuff, and I've done my best. Believe me, I've spent hours trying to figure out the best way to do it and make it work. But why? I could just do it this way, and it's so much simpler. So this completely just eliminates the need for me to do object inheritance. And with JavaScript, it doesn't matter what object I pass in here because it's not strongly typed. So I could pass in any object as long as it has an X property. It's going to be able to get the left. It's going to be able to get that X property and return it. So it works out fine, at least for me in JavaScript. So this is the object composition. I will mention one other thing here. and it's kind of a question for you guys. So if you know the answer, go ahead and put it in the comments. What I'm doing here is I'm using the spread syntax to copy the properties off of this rectangle 2D object that gets created here, and I'm copying them into this player object that's getting created here. The problem with doing it this way is I am creating an object. I'm creating a rectangle object. So I'm creating this object right here. And then I am copying those properties off of that object into this object right here. That object that gets created gets garbage collected. I copy the properties on it and then it just gets garbage collected. My question is, would it be better to do this like this? rectangle2d.create.call. I think that's how you do it. See if I catastrophically broke anything. No, I did not. Good. Is it better to do it like this with the call? So the idea would be that I'm not actually creating another object. I am calling the create method on this object. I don't think this actually works though, because if we go into rectangle 2D, we can see that the create method is returning a new object. So I think either way I'm creating a new object. That's the wrong file, but I'll go ahead and save that. Either way I'm creating a new object, I think. So, but I would like to do it in a way where I don't create a new object so I don't have to garbage collect it. So if I can get that to work, I think that would be really cool. So for now, I'll just go back to the way I had it, but if anyone has an answer to that question, go ahead and leave it in the comments because I would be very interested to know. And just check to see if I broke anything there with that edit, and I did not, so we're good. All right, so that is basically my implementation of object composition, and I kind of gave a more in-depth explanation of the utilities. I hope that is helpful to you guys. And now on to the next part. All right, so now let's take a look at some fun stuff. The Dominique graphic actually changes directions now depending on which way you face. And the way I did that was with the canvas's scale method. So I think canvas rendering context 2d.scale. Let's take a look at that. I'll go ahead and shrink this down a little bit. I created a utility for buffer. Buffer utility just creates a canvas rendering context, and that's the buffer object. We have a draw method and we have a draw flipped x method. So in the run game state, in the render method, when it comes time to draw the player, we just use draw flipped x instead of the regular draw method. So let's take a look at the draw flipped x, and it should be pretty self-explanatory. So draw flipped x just takes the buffer we're drawing to, the image we're drawing, the x and y position of that image, and the scale x value. And for us, that's either going to be 1 or -1, because on the player, when we do move left or move right, we have this new property called direction. If we're moving right, we set direction to 1. If we're moving left, we set direction to -1. And then in the run game state, we pass it in here as the last parameter, player.direction. And then inside of the buffer, we get that direction value as scale x parameter here. So if we passed in -1 because the player is facing left, then we scale the entire buffer. So the entire display buffer, which is what we would be drawing to, gets flipped around. So we're not flipping the player image, we're actually flipping the entire screen basically around. Then we draw our player image. And the reason it's important to note that we're flipping the screen is because when you draw your player image, you're going to have to do a little bit of an offset to draw it in the right place. So right here, I'm subtracting image width. If I cut that out and I save and I refresh, let's take a look at what happens. When I'm going right, nothing happens because direction is +1. But when I try to go left, you can see all of a sudden it just jumps. Like I just jumped to the opposite direction. Bam. So the reason for that is because the X position of the player is on the left side of the graphic. And when we flip the screen and draw it, we're still drawing at that X position on the left side of the graphic. It's not centered, so we're not rotating on the center. So we just need to offset for width. So that's all that I do. So in here, we just subtract image.width, and that's going to be the offset we need. So when we save it and refresh, now we get that nice smooth like flip across the center of the player image that you would expect. But really what's happening is we're flipping the entire back buffer. We also need to draw at -X because obviously the buffer is flipped, so things are in reverse. So we just flip X. Then when we're done, we scale the buffer back to the proper direction. And we do that by multiplying by -1 again. So if scale X is -1, we flip it, we multiply X or width by -1, right? And then we draw the image with the offset, and then we scale again, flip it back. If scale is not -1, I'm not even going to scale anything because I imagine this is an expensive operation. I would rather just make another call to draw image, to draw as we normally would. Another thing is I broke out the draw calls with draw image into this buffer utility. The reason I did that is because I am just putting math.floor in here. I don't want to have to remember to put math.floor in every time I want to call the draw method, right? Math.floor just clamps our image to a solid integer rather than a fraction of an integer. So basically that's just going to allow us to draw more crisp pixels, right? Because they're being drawn in pixel perfect position because we're rounding to the nearest pixel perfect position with math.floor, or actually rounding down with math.floor. So that's another reason I broke this out into its own buffer utility. I don't really have much more to say, but this is a cool way to do it if you just want to flip your graphic around. The other way, which I actually prefer a little bit, is if we take a look at the images and go to the Dominique image. The way that I would do this, and I probably will do this, is just to draw another Dominique image and flip it and put it in this tile sheet, and then do what I do with frames like I do with the text image, and just switch frames. So instead of flipping the display buffer, I'll just draw the next frame in the image. I would just have to draw that image out and include it in the Dominique image. So I would add a little bit extra to this file size, but it's not like a killer. Plus, the cool thing about that is you can customize the graphic a little bit, which I think is always a nice touch. So like you keep the shadows on the right side instead of flipping it. Like images in games that have shadows, if you're flipping it, obviously the shadow is suddenly facing the wrong direction. It doesn't make any sense. So that's another reason that you might want to just draw it out and do it that way. But yeah, so that's how you flip the graphic. Now let's take a look at collision. I added some collision methods to keep things in bounds that we didn't have before. So when you jump off the side of the screen, it kind of pushes you back on in like a kind of a bouncy way, which I kind of like. I like it a little bit better than just hitting the side of the screen and just being like a hard stop right there at the side of the screen. With this, it kind of like bounces you back in, and you can also kind of like cheat a little bit and jump off the edge of the platform, which I think is important because it's easy to get stuck on the spikes. So you want to give people a way to get away. Man, that thing is hard to catch. But anyway, let's take a look at the collision utility that I made to handle that method. I'll show you the method, but it's extremely simple. So the collider utility is going to live in the utilities object here. We go back over, check out the collider utility. So here's the collider utility. It depends on Rectangle 2D for a lot of its methods, because Rectangle 2D is like the base object for the player object and the item object and the platform object. So everything basically uses rectangle properties, and these methods are going to make use of some Rectangle 2D methods. So I moved all of the collision methods from the run game state out of the run game state, and I put them in this utility. But let's go to the ones that are relevant here. Keep player in bounds. It's extremely simple. In the run game state, try to find it. Keep player in bounds. The way we call the method is just with the utility name, so collider.keepPlayerInBounds. And then we pass in the object that we want to keep in bounds, and then we define those bounds. So left would be 0 because it's the far left side of the screen, and right would be 256 because that's the width of our game board here, if you want to call it a game board. And then all that happens is we see if rectangle 2d.getLeft player, so that just gets the left side of the player, is less than left, set player.velocityx to player.velocityx plus 1. So we just add 1 to player velocity x. Else, if we get the right side of the player and it's greater than the right hand boundary, so if the right side of the player is greater than 256, then we subtract 1 from player velocity x on every frame. So that's, as long as we're past that right side of the screen, it subtracts 1 from velocity x on every frame, and that's why we get that push out, that gradual kind of bounce, because right now our velocity x is like negative, I don't know, maybe like -3 or something like that, and then it gradually just fades away as friction is applied. So that's our keep player in bounds method. I have the same similar thing for keep item in bounds. Works a little bit differently because the item has to stay in top bounds as well. So the item can't go above the top. The item can't go, dang it, can't catch that thing. Can't go below the bottom, but it's the same. It's basically the same thing, just adjusted so it also considers the top and bottom. So we got get left, get right, get top, get bottom, and it just checks to see what's going on. The difference with the item is the item's direction works on rotation. So it's based on rotation. So when the item goes off the left side of the screen, we rotate the item 180 degrees. 180 degrees in radians is just pi. So we're just going to add pi to the rotation of the item, and that's going to send it, if it's running away from us. There's no way I'm even going to be able to show you this because the AI is like way out of control. The item is way too fast. But it'll just reverse the rotation of the item and it will go in the opposite direction. That's a cool thing that you can see here. So when we're chasing it across the bottom, the rotation wants to point up, but because we're chasing it, well, I'll get into the AI in a minute, it actually like loops back underneath the player. Caught it there. All right. But anyway, so that's just some really simple collision with the sides, and this is a good example of a collision utility. All right, so the last thing I want to talk about is the diamond behavior. So I'm just going to briefly go over it because it's not really where I want it to be just yet, but I will show the code so you can copy that and mess around with it. But basically what I'm going for here is I want this thing to meander around the screen, just kind of in like a sweeping, kind of meandering pattern, almost just taking like these S-shaped paths just all over the screen until you get in a certain range of it. And at that point, I want it to run away. And I want the speed of it to be based on the distance that it is away from the player. So I kind of have that working. The meandering is not really working at all, or it is, it's just working very slowly. So if I were to speed that up, I can come into the code here. This update position method is located on the item utility, so staydown.utilities.item. I have a method here to create an item object. It just has R, which is for the rotation in radians, then velocity R, which is the amount we add to rotation. on every frame. Then we've got velocity X and Y, and then it just has the rectangle properties. So update position is called in the main game loop in the update function of the run game state. So I pass in the item itself so we can manipulate its properties, pass in the center X and Y position of the player, and I pass in friction, and friction you can see is just used down here to slow down the rotation and X and Y velocities. So basically I'm setting speed to this right here. Basically it's just an arbitrary value that I just tweak to get it how I want it, divided by the distance, and distance is the distance squared from the player to the diamond. So if the distance is 200 or 300 pixels or 100 pixels or whatever, then it's going to be 100 times 100. It's going to be that distance squared. And the reason I'm not taking the square root to get the actual distance in pixels is because I just don't need to. Everything works. The only problem with that is you have to work with these very large, seemingly arbitrary values. But let me go ahead and tweak this just to show you what I'm talking about here, because the speed of the diamond is based on distance. So here you can kind of see a little bit more of what I'm going for. You can see this thing kind of, it's like jumping around the screen. It's doing something, but it's really jittery if I increase the speed too much. And I think the main issue I'm having is the rotation. Like I'm adding to the rotation with just math.random on every frame. So it's not very smooth. So it's kind of jittering all over the place. And I can speed up like how fast it moves with speed, but even then you just see the rotation is just all over the place. It's not very smooth at all. But basically what I'm going for here is I want it to kind of meander around, and then when I get close to it, I want it to run away. And I kind of have that working, but not quite. So I figured since I already have it in the project, I would show it in the video, but I'm not really going to go over it in great detail. But here is the code if you want to copy it out and mess around with it yourself. Basically it just creates a vector from the player to the diamond item, creates another vector, just a horizontal vector that is meant to be a rotation of 0. So I'll have like my rotation of 0 vector, and then I'll have my vector to the player, from the player to the diamond, and I'll calculate the angle between those two vectors, and that will give me the rotation. When I get close enough to the diamond, this code here with the cross product and dot product and math.atan2 calculates the rotation of that line. So I basically just set the rotation of the diamond to that line between the player and the diamond, and it moves on that rotational angle. So that's how we're making it escape from the player. And I might just change how that works a little bit too, because I don't think I need to do that with rotation, but we'll see how it goes. But I just wanted to show you this and talk a little bit about where I want to go with this behavior. And feel free to copy this code. I'll have a link in the description to the source code and everything. So play around with it if you want. Maybe you can beat me to the punch, because I should have this sorted out by the next video. Alright, so there you have it. Part 17 of the Stay Down devlog is done. If you guys have any questions about anything I covered in this video, go ahead and leave a comment. I'll try to get back to it. I've been gone for a while, but I'm going to try to get back into this a little more. And basically just finish this project. If I could just finish this project, that would be a huge milestone, and then I can go from there. So leave a comment if you have any questions, like the video if you learned something, and I'll see you in the next video.